All right, so for today, we're starting with linear functions and reviewing those. So the main equations we need for this, and just a side note, I gave you equations here. I do not give you equations on the test itself. So just FYI, things we have to know. Okay, 2 equations we will need to know for this. Equations of lines are always in the form y equals mx plus b. That is your final form. It's not always where you start. You may use that to start with. I've seen people do that to solve. Some of you are comfortable doing that. I use point slope form, which is y minus y1 equals m times x minus x1 for the ones that we need to start out in a different form and then solve. It depends on what you are given as to which one you use. Y equals mx plus b is generally called slope-intercept form, literally because it gives you the slope, which is your m, and it gives you the y-intercept, which is your b. So if you are in an example like number 1 here, I am given my slope, that's my m, I'm given my y-intercept, that is my b. I don't have anything to solve for in that one. All I have to do is take those numbers and plug them in. Okay, those are like your gimme problems. They should be the easiest ones on the test. This one, your equation of your line should be y equals negative 2/3 x minus 1. All you're doing is plugging it in that case. Okay. Other ones, you will need to plug it into your point slope form, which is this one. Again, it's called point slope form because you're literally in here given a point, which is your x1, y1, and you're given your slope, which is your m. Okay, so the names for these literally tell you what they're talking about. You'll use that one when you're given a point and a slope, and you have to solve for slope-intercept form on that. Now, there's always special cases. Special cases are like number 2. Anyone remember horizontal lines, what those equations look like? Y equals, good. If they say a horizontal line, it is simply y equals a number. There is no slope for that. There is no x in that formula. What is the y value in the point that they have given me there? Negative 1. So simply y equals negative 1. Okay. While we're there, this is not a question written there. What if instead of a horizontal line, it said a vertical line through that point? What kind of equations do vertical lines have? X equals a number. Again, there's no work involved in this at all. You're simply saying x equals whatever number it goes through, which in this case the x value is what? 5. Okay. So the first 2 questions here, these are no work at all. You're simply plugging in numbers. You just have to know the format that you're plugging them into. Okay? So while they're the easiest questions on the test and quiz, for some people they're also the hardest because if you don't know it, you simply don't know it. You can't actually like figure your way around to it. You either know it or you don't. Those are simple things to kind of look at. Then we get to questions like 3 and 4. On questions 3 and 4, okay, we're looking at different kind of information given. So in question 3, we're given 2 points. I don't have an equation that we've written up there that says 2-point form, do I? I have point slope and I have slope intercept. If I do have 2 points, however, what can I find from those 2 points? Slope. All right, so here's another good equation to remember. Slope formula. Rise over run, or y2 minus y1 over x2 minus x1. All right? So if we take a minute, the first thing we're going to do is find your slope. Does it matter which point is x1, y1, and which point is x2, y2? It doesn't matter as long as you stay consistent. If I pick negative 1 as my y2, then negative 7 has to be my x2. I got to stick with the point I start with, okay? But it doesn't matter which one you start with. So in this case, I could do negative 1 minus negative 3. If I choose to start with negative 1 on the top, I must start with negative 7 on the bottom. That's the most common way people get these questions wrong, flipping those top and bottom. Then in that case I would do -7 minus 5. We will always leave slope in fraction form. Remember, on top, 2 negatives turn into a positive. -1 plus 3 gives me 2. -7 minus 5 gives me -12, and I reduce this to -1/6. Now, once I have my slope, now I can go use that point slope form. Okay? Again, this is where you plug in your slope that we just found. So this is my -1/6, this is my m. And this is where I also plug in a point. Now, does it matter which point I choose? Again, it doesn't matter, as long as you stick with the same point. If I use 5 for my x, I got to use -3 for my y. Okay? Just don't mix and match the points. So when I plug that in now, it's going to look like, there sometimes is an easier point to plug in than others. In this case, there's not. So we can just pick 5, -3. If you do a different one, it's totally fine. If I do that, I'm going to do y minus, my y value is -3, equals, my m is -1/6, x minus 5. Can't leave it in this form. I want it to say y equals before I'm done. So now my job is to simplify. What's my first step in simplifying? The parentheses, dealing with the parentheses and distributing. These kind of questions will be on non-calculator sections, mostly because I expect you to be able to multiply fractions by hand. That's just something we're going to do. So as I do that, y minus a -3 turns into y plus 3. And I distribute my -1/6. When I distribute it to the x, it becomes -1/6 times x. When I distribute -1/6 times -5, remember when you're multiplying a fraction by a whole number, you put the whole number over 1, you multiply the tops, you multiply the bottoms. If you know exactly what to do with this, and I'm doing too many details for you, I'm sorry, but it's been the summer, and some people know how to do this, and frankly, with fractions, some people don't. Okay, some people, we've hit junior and senior year and we still don't know how to multiply fractions. So at least once, I'm going to go through it. I won't be going through the steps every single time, but I will do it the first time. Okay? All right, so if I multiply the tops and I multiply the bottoms on that, -1 times -5 gives me +5. 6 times 1 gives me 6. Now our last step to get y by itself is going to be what? Subtract the 3. Now, again, this is something we may or may not know how to do because I have to combine that 5/6 minus the 3. In order to subtract fractions, what do we need? Common denominator. So that means I need to put that 3 over a 1, and I need to make it have the same denominator as the 5/6, which is 6. So I need to take this fraction, I need to multiply it by what? 6, top and bottom. Which means I'm actually subtracting 5/6 minus 18/6. So to get my final answer, I have y equals -1/6 x, 5/6 minus 18/6. Remember, when you subtract fractions, you just subtract the tops and keep the common denominator. So in this case, that's going to give me a y-intercept of what? -13/6. All right. That has been the most complicated question probably that we've done yet today. Lots of fun. I know. All right. Wherever you have some blank space on the side of this paper, on the bookwork page, I don't care where, just find a blank spot for me. We're going to try another practice problem like that. I'm going to make it up, which probably means it's going to have some nasty fractions. Yay. All right, so same exact type of question. Through the point, 4, -1, and -3, -5. All right, so this is practice for you. If you get in question 4 now, we are going to be finding our slope a little bit differently. So because it says parallel to this line, that means we're going to be getting our slope from the line given. If it's parallel to a line, it means it has the same slope. So first and foremost, I need to figure out what is the slope of that line. Currently, you can't tell me what the slope is because it's not solved for what? Y. Okay, so don't make the mistake of saying whatever's in front of x is my slope. Not until it's y equals. So first, let's just practice that. This is a good skill to try to remember. If I want to make it say y equals, what do I have to move to the other side first? The 3x. Subtract 3x from both sides. This gives me negative 4y is equal to negative 3x plus 7. Then to get y by itself, I have to get rid of what? The negative 4. So we divide everything by negative 4. And we end up with some lovely fractions again. Negative over a negative for our slope makes a positive 3/4. And negative 7/4 for my y-intercept, which I actually don't care about at all. If it's parallel, all I care about is I take this exact slope, I bring it over here with the point that has been given to me, and I use it to write the equation of a line. We just did that exact process in question 3, only we had to find our slope a little bit differently. We found our slope through the 2 points. This one we're finding our slope from a line. So if I have a point and a slope, I can go directly to point slope form. So if I set this up, I'm going to do y minus y1, which in this case is going to be what? Negative 1 is equal to 3/4 times x minus my x value, which is the 6. I'm going to pause here and let you finish that out, mainly to practice the fractions. All right, so, ooh, no, darn it, erased that. Okay, so we had y minus negative 1 equals 3/4 times x minus 6. So we would have started this by 2 negatives, make a positive here, y plus 1, and then distributing your 3/4. So you can reduce here, or you can reduce later. It doesn't matter. Some people would have kept the 18/4 and subtracted your 1, which is totally fine. You're just going to get a common denominator of 4 instead of 2. Or you could have reduced it here and made it 3/4 x minus 9/2. And then when we subtracted 1, made it a common denominator of 2. Either way, we should have ended up with 3/4 x minus 11/2, which I would have been okay with that as a decimal. You could say negative 5.5 on that one. If we were graphing, I'm not graphing a y-intercept of negative 11/2. Like, that's not where I go with that one. I would go with the negative 5.5 because I can actually graph that. Okay? Questions on that one? All right, flip over to the back for me. Finish up real quick with some of these in systems. 6 has a lot of complicated information for you. However, it ends up being very quick as long as you know what you're doing. First, undefined slope. Anyone remember what undefined slope means? Or what it's associated with? Vertical lines. Good. We talked quickly about vertical lines on the front page. If you need to flip back and take a look at that. Vertical lines have what kind of equations? X equals a number. Okay, so if I can simply figure out what number that's going through, I'll be good. So it says vertical or undefined slope, so that tells me a vertical line with the same x-intercept. That's our other key word here. Okay, in order to be able to solve this, I need to know how to find an x-intercept. Y-intercepts are easy. Solve the equation for y equals mx plus b, and that's that b part at the end. Okay? X-intercepts. Anyone remember how to find those? The easiest way. Plug in 0 for what? For y. Yes. The one that you're not trying to find. You want to be able to solve for x, so you don't want to be plugging in anything for x. So if I take this equation and I take out this y right here and I plug in 0, that's going to give me 3x plus 2 times 0 equals negative 6. Well, a lot of us know and don't even have to show that step, because if I do 2 times 0, it's just going to simply do what? Get rid of that whole thing there and just leave me the 3x equals negative 6. Solving that for x is going to give me what? -2. Now, we already said we're looking for a vertical line that has the equation x equals a number. And it goes through the same x-intercept as this one. Do I have to do anything with this? No. This is the equation of a vertical line. It goes through that. Goes through that same x value. That is actually my answer. Okay? So that one didn't have a whole lot of work to it, but you do have to know how to find x-intercepts. Okay? On the flip side of it, if you did want to find a y-intercept without solving for y, you could plug in 0 for x as well. So that flip-flops. A couple quick formulas to review before we talk systems of equations. Distance formula is something that is helpful for you to have if you do need to find the distance between 2 points, or if you're given a figure on a graph and you need to find the length of a side. You'll see that a lot on the SATs and ACTs. Some of you are still taking those, so we'll go over some stuff here and there with that. Here's your distance formula. I'm going to run out of room here. Sorry. Like that. That's all under the square root. x2 minus x1 squared plus y2 minus y1 squared. Now this we typically do by hand without a calculator unless you want to do everything but the square root in your calculator. If you do type in the square root, it's going to give you a decimal answer. Typically, we don't do decimal answers for these. We do simplified square roots, which this is a great time to practice that. So if I plug this in, it's similar to the slope in that there's x2, x1, all that good stuff. Does it matter which one I choose as my x2, y2? Again, no. So most of us choose the second point as the x2, y2 just because we're used to it. So I would set this up as 7 minus -3 squared, bless you, plus 2 minus 5 squared. If I'm doing this by hand, I do 2 steps at once typically, because I know 7 minus -3 turns into 10. When I square 10, it gives me 100. Plus 2 minus 5 gives me -3. When I square -3, that gives me positive what? 9. So this is going to give me the square root of 109. Now, simplified square roots means I look for anything that goes into 109 that I can square root. In this case, there isn't anything. I would try to divide 109 by different numbers. It's not going to divide by 2. It's not going to divide by 3. You know, go through a couple of them and make sure, see what you can get to come out of that. If there is something, if there's not, you just leave it here, and that's okay. I'd prefer this to a decimal. The difference will be is if we do real life problems, when we're starting to talk word problems on different things, then we'll typically do decimals because we're not used to seeing square root answers for those. It's not like you say the square root of 109 miles. It doesn't work that way. So we'll do that then. But, all right, midpoint. Midpoint formula is the last formula we're talking about today. That one is an average, x1 plus x2 over 2, comma, y1 plus y2 over 2. Remember, midpoint is actually an xy point. So you're getting 2 numbers for these, an x and a y, separately. So in this case, we're going to go ahead and add our x's. -3 plus 7 divided by 2. We're going to add our y's. 5 plus 2 divided by 2. Here's another case that when you're dividing by 2, a decimal is perfectly okay, especially because a lot of times we graph these. So -3 plus 7 gives me 4. When I divide by 2, it gives me a nice even number. 5 plus 2 gives me 7 over 2. You can leave it as 7 over 2, or you can divide and give me a decimal, which is 3.5, because we graph that a little bit more than 7 over 2. Okay. Our last thing that we're reviewing today is systems of equations. We're going to start by doing these by hand, but I'd also like to review how to do these using matrices on your calculator, because that tends to be the easiest way to solve them. Especially when you hit these on the SATs or ACTs, you want to go quickly on questions like this. So that's something we'll talk about real quick too. that I'll show on a calculator on the screen so that you can follow along with me if you have your calculator. And if you don't have an Inspire calculator, I'm recording these lessons to post on the Canvas website, so you can go back and look at the recording to see how to do that if you go get an Inspire or you didn't have yours today or whatever. So you can go back and look at that. Now, solving systems of equations, we have 3 ways of doing that. The most inefficient way is to typically graph the lines and see where they cross. Anyone remember one of the other methods? Elimination. Elimination is where we typically multiply by numbers to make our x's or our y's match and cancel out either our x's or our y's. The other way we typically use is substitution. Substitution is where we're solved for x or y in one equation and we substitute that into the other equation. If I look at questions 9 and 10, one of them set up for elimination, one of them set up for substitution. Any ideas which is which? Anyone take a guess at either one? 10, I would say, is the best for substitution, and here's why. Look at the second equation. What's the second equation solved for? Y. Y is already equal to something, which means that the way we do substitution is we take what y is equal to, we go to the top equation, we take out the y, and in place of the y, we put what y is equal to, which in this case is what? 6x. What that does is it creates for us an equation that's either all x's or all y's, and it makes it much easier for us to solve, because I can combine like terms here, right? 3x minus 6x is going to give me what? Negative 3x equals 6. Then I can solve for my x value by dividing by negative 3 both sides, which gives me x is negative 2. Now in systems of equations, I'm not done when I get x equals. I need 2 parts to each of these, an x and a y. So where do I go to find my y value now? I plug it in back where it was solved for y. I take out the x, I plug in my x value of negative 2, and that gives me my y is equal to what? Negative 12. So your answer for systems of equations are typically ordered pairs, an x and a y, written like that. Okay. Substitution, I only use when it's easily solved for either x or y, or it's already solved for x or y. 9 you could solve for x or y in several of those, but I say it's set up for elimination because I look at these y values right here, and it's going to be very easy to cancel them out because they have the same number in front of them. In this case, they're both 1y, but it could be any number as long as it's easily set up so that it's the same number in front of it. Now in this case, if I went and added straight down my columns, that's not going to help me because that's not going to cancel out either my x's or my y's. If instead of adding, I did what? Okay, I can multiply by a negative, or I can just subtract instead. If I make this a big subtraction problem and I subtract each part of this, as long as I subtract my x's, my y's, and my numbers, which are all lined up on top of each other, I'm allowed to do that. If I take my x's first, x minus 2x straight down that first column is going to give me what? Bless you. X minus 2x. Negative x. Y minus y cancels out, which is exactly what I want it to do. That's the point of elimination. We have now just eliminated the y. 7 minus 5 gives me 2. All I have to do is get rid of the negative in front of the x now. Dividing both sides by negative 1, or multiplying by negative 1, or just flipping the sign, whichever one works for you, gives me x is negative 2. Now with elimination, you have options where you plug this back in. You can plug it into either equation. That's totally fine. I usually pick whichever one looks the easiest, which in this case for me would be the first one. So if I take that first equation and I bring it down here, I plug in a negative 2 for an x value. I can then pretty easily solve for y. Adding 2 to both sides gives me y is 9. Okay. Now I want to take a minute and do the same exact problems using matrices with our calculator. So if you do have a calculator, grab that. I'm not going to show how to do this on the 84 because to try to flip back and forth between the two right now in class is super complicated and not conducive to class. If you do have an 84 and want to know how to do that, let me know. I can help. But let me pull up my calculator real quick. And we will do that. All right, so on a normal calculator screen for yourself here, what we do when we do matrices, actually I'm going to flip back to the notes quick to show you what they look like. Matrices for something like this, first you just have to set up your matrices, which if you remember are these little brackets. Okay. We have two matrices for a system. We have the coefficient matrix from the left, and we have the answer matrix from the right. So the coefficient matrix, you're literally just pulling out the numbers in front of the x's and the y's. So for this, you have a 1 in front of this x, a 1 in front of this y, a 2 in front of this x, and a 1 in front of that y. That's going to be my first matrix. Okay, we're going to call this one matrix A. My answer matrix is literally just the answers. So in this case, that's going to be 7 and 5. We always call that matrix B. There's like a whole proof of why this works. If you're one of those people that really wants to know the why and the how, there's a way to do this by hand that I can show you. Most of you will not want to do that. It's easier just to type it into your calculator. Once you know what your matrices are like this, all you're going to do is set them up in your calculator, and you're always going to do A inverse times matrix B. And that will spit out the answers for X and Y at you. Like I said, I can show you exactly why. I've taken a whole class in matrices and how to do this, but for the sake of time and the fact that you're not math majors that really need to do this by hand, I'm just going to show anyone who's interested for that. So how we set this up in our calculators then. Am I okay to erase this real quick? Okay, I'm going to flip back to my calculator to show you how to do that. On your calculators, first we just have to enter the matrices. So the first thing we do to enter those, right next to the number 9 right here, there's a little menu. If I click this menu, it brings up a whole, I call this the templates menu. The templates menu has fractions, it has exponents, square roots, it has all sorts of different things. We're going to use the piecewise functions over here later, but matrices are right down here on this, the middle part of the second row. You can see the square brackets. There's 2 or 3 specific matrices, like this one is that square one that we have on the left hand side from our coefficients, and then this third one over here is the answer matrix. If you click the fourth one over here, it's just going to give you options. You can make a matrix as big as you want. Okay, so if you're ever not sure what kind, you just grab this one and you can tell it the number of rows and numbers of columns. But for the sake of ours, this first square one will work, so I'll click that. And right now I'm just simply going to tell it what matrix A is. We said that was 1, 1, 2, 1. Now we also have to tell it a name. To tell it a name, we're going to use the store button, which is right around the same spot. It's this one that says variable. Right above it, if you see in blue, it says STO. Okay? So if I do control and then variable, it gives me a little arrow, which it's telling you right now I'm taking this. So for this one, if we did our coefficient matrix here, it would be 3, 0, negative 1, 1, and or never mind, excuse me, I'm reading this wrong. Before I set that up, what do I have to do to this equation here? I got to move the x to the left. It's going to have a 0 in the other side, but I have to set this up right. So in this case, the first equation would stay the same. I'd move the x to the left by subtracting it, and then once it's set up correctly, then I can make my matrices for this. So 3, negative 1, negative 6, 1. My answer matrix would be 6, 0, and I would enter that in the same exact way in my calculator. Type in matrix A, type in matrix B, A inverse times B. It seems like a lot of setup for something that's pretty simple. So for something like number 10, it's real easy to solve that by hand. If I was doing that on the SATs or ACTs, I know how to solve that real quick. Where does this come in handy a lot is when it gets to like 3 variable ones. 3 variables are a pain in the butt to solve on your own. I don't even like doing that, and I like doing math. So that's the ones where I really use the matrices, but it's just a good tool to have when we can use our calculators. Okay? So what we're going to do here is we're going to take a minute in groups, and we are going to practice with systems of equations.